Now we are going to solve the logarithmic problems. Okay, problems involving logarithms. Still, we studied the theory of logarithm and what is the exponential function, what is logarithmic function, and what are the graphs of logarithmic function and exponential function. Now we are going to learn how to solve problems involving logarithm. Now let's solve first the problem involving exponential functions. You will see here 1 minus 5 to the power x upon 7 to the power minus x minus 7 is equal to 0. We have to find the values of x. We have to find the values of x such that this equation becomes true. Now you will see that 1 minus 5 to the power x and upon 7 to the power minus x minus 7 is greater equal to 0. Here this term is going to be, this term has negative value and this term involving x has positive sign. So first we make this term positive. If we are going to make this term positive, then what will happen? Then 5 to the power x multiplying both sides by minus 1, 5 to the power x minus 1 upon 7 to the power minus x minus 7. When you multiply this term right hand side by minus 1, then the inequality will become, inequality reverses, so it will become less than equal to 0. Now we have this equation. So now we will solve. For example, 5 to the power x minus 1 is equal to 0 when, and 7 to the power minus x minus 7 is not equal to 0. If this becomes 0, then the whole equation, then the RHS will become 1 by 0 is equal to infinity, but our RHS is less than equal to 0. So this cannot become 0. When it will become 0, 5x to the power 1, x is equal to 0. Okay, and this 7 to the power minus x is equal to 7, x is equal to minus x is equal to 1, x is equal to minus 1. We get, now our equation is saying less than equal to 0. This equation gives the value which should be less than equal to 0. So by using sign conventions, we will say that for minus 1 and 0, and our value should be less than equal to 0. So sign conventions will say that this should be minus, plus and minus. So our range will be x belongs to minus infinity less than 0. So by sign conventions, this range will be accepted and this range will be accepted. So minus infinity, minus 1 should be closed or open? Minus 1 should be open, because x 7 to the power minus x minus 7 is not equal to 0, is not equal to 1, is not equal to 1, is not equal to minus 1 to the power minus 1, including this term. This is numerator can be 0 because here is equality sign, it can be 0. So x is equal to 0, union close 0 to infinity. This is the solution for this equation. Okay, now we are going to see the second problem, which is greater. Either x is equal to log 5 to the base 3 or y is equal to log 25 to the base 17. Let's solve this. We see that this is 5, this is 5 and this is 25, 5 to the power 2. So if we take 5 as base, then what will happen? 1 upon x is equal to log 5 to the base 3. By using logarithmic properties, we will write like that, and we will write this as log 17 to the base 25, 1 upon y is equal to. So if we simplify further, then it will become log 5 to the power 2, 17 to the base 5 to the power 2. This will become 1 by 2. When 2 will goes here, it will become 1 by 2. Log 17 to the base 5, 1 by y. So here we will write this log root 17 5, 1 by y. and here 1 by x is equals to log 3 to the base 5. Now we can compare these two both as 1 by x log 3 to the base 5, 1 by y log 17 to the base under root log 17 under root 17 to the base 5. This is log 7 under root 17 is greater than 4. So we can say that greater than 4 and this is 3. So 1 by y will be greater than 1 by x. Therefore x is greater than y. This is the way you should solve the problems. First, try to solve simple problems in order to gain confidence. Okay? And after that, try solving a very difficult try to improve yourself with solving simple problem first, then a difficult problems. Okay? Thank you.